All right, so welcome to module 6 in the Pawsey user training about using software containers. This is module 6 out of 11 of the series. The learning outcomes for the module include describing the what and the why of software containers, especially in the context of supercomputing, and then examples, hands-on examples on how to download and use them, including how to use container modules for a streamlined container experience on Cetonix. Watch out for the signs over the presentation. They highlight key callouts for this module. So software containers. So what are they? First thing. So a container is a kind of it's a unit of software. You can think about that as a sandbox of software that isolates a specific application and all its dependencies in the same place, in the same box. The box can be carried anywhere on any machine over time, different computers, different users. All of the dependencies of the application are inside this box. The only external requirement are a so-called container runtime to execute the box and the underlying operating system to make the computer actually work. So what's a container runtime? Well, it's just a utility that is required in order to manage and use containers. So we've been using containers for quite a while now at Pawsey. Why? So there are some advantages, especially improved reproducibility and portability across infrastructure, different centers, different shell environments, even over time, so subsequent installations. Productivity advantages, you build the container once, or maybe someone else has built it for you, but then you just download and run it. It's ready to go. So a simple installation method. And with these advantages, we still retain or even sometimes improve the scalability of the software. So when I say keep the same scalability, it's because MPI applications in containers are able to run with the same performance as a non-container application. When I say improve, so in the case of some workflows, the I/O performance of some workflows can even improve when using a container on a parallel file system such as Scratch compared to a standard installation. There are, like everything, there are some possible drawbacks. If you want to achieve true cross-infrastructure, cross-architecture portability, you may need to renounce some of the performance optimizations of the application. This is normally not too big hit, but it's worth mentioning. The installation of the container runtime requires the system administrator of the machine action, and this has been done at Pawsey, so it's been taken care of for you. And the MPI support also requires some tuning by the support staff, and that's been done for you as well. Just to give you some examples of good user cases for containers that we've encountered in the previous years. So large volume of software to be installed, such as in the life sciences, where we used to get requests for several tens of different packages to be installed, even just by a single research group. So containers make the process of deployment more effective, more time effective. Another good use case is when there are quite very complex build processes with a lot of dependencies. And there's an example out of many is the case of deep learning frameworks. Other cases are dependency trees of the applications with high chances of package or version conflicts, and I'm thinking about Python and R workflows in particular. And then in this case, containerizing the workflow just makes the managing the conflicts of packages easier, because each container will just include the packages you need for that specific workflow, and without crossing with other workflows that you need to run. This is a similar case again when you have a dependency tree with hundreds of small packages and dependencies. And this happens, for instance, in Python installations. This is one of the cases where the single container file improves performance on the Scratch file system, on the parallel file system. And another example is intensive I/O patterns that create a lot of small files. And we had a typical example at Pawsey with OpenFOAM, a package for computational fluid dynamics. And again, in this case, using the single container file in a specific setup can improve performance on the file system. So how do we support containers at Pawsey? Well, we do provide a container runtime called Singularity as a system module. We talked about module in the previous training module. What this means essentially is that you can go module load Singularity in the version, and the container runtime is already available for you to use. Singularity has been configured so that all of the relevant file systems, Scratch in particular, is always available in the container. API performance have been tuned by Pawsey staff. Another way we are supporting containers is also providing an option to install container software as container modules. We'll see that towards the end of this module, that this is a way to reduce the learning curve to run containers. And we also provide a small collection of Pawsey curated container images for MPI, a base for MPI installations, Python containers, OpenFOAM containers. So that being said, that was just an introduction. Let's now move on to the hands-on component to show you what it feels like to use containers on Cetonix. Before doing that, just a small definition. I'm going to call container tags. A container tag is what we typically use to specify the version of a container. It is custom specified by whoever built the container. It usually contains the version of the package. It can also contain additional strings. With that being said, let me now go to the web browser. Before running on Cetonix, I want to show you how you can use some online available container registries to scan for already available containers, which can save you a lot of time in actually figuring out how to deploy applications as containers. So one of the more popular container registries, which is a place where you can actually find third-party containers, is Docker Hub, which you can access on hub.docker.com. In this example, I'm going to take it very simple. I'm just going to look for a container for the Ubuntu Linux distribution. And there is, in fact, this is the official home for the Ubuntu containers. And let me click on here. You can typically we find information on these containers, the versions, and whatsoever. The key place to go is the tags section. This is where you can look for the actual container versions. And these are the tags I just mentioned to you. I want to look for a Ubuntu container, which is specifically the version. Let's actually go with 2204. That's the latest available Ubuntu distribution. When I select that, here is the tag. If I click on that, they changed the layout slightly. So let me redo it. So when I identify the tag of interest, I'm going to move on the right here. And I can actually just copy paste the name of the container from here, forgetting about this first part. So forget about Docker pool. This is for other setups, but the second part is the important one. Let's do it this way. This is short. I could type it, but I'm going to go lazy instead. So I'm going to use the icon to copy this string. And then now let's move on to Cetonix. Now I want to install and run this Ubuntu container on Cetonix. Let's see how we go. You can imagine installing an operating system can be time consuming. When now we're using the container, it's already there for you to be used with some minimal functionality. So I'm now on Cetonix. Let me first load the module. So let me enable the container runtime Singularity on Cetonix by using the command module load Singularity and the version as shown in the previous module on modules. Okay, how to download that Ubuntu container. So the syntax with Singularity is Singularity pool. And then you typically need to provide this prefix here, docker:// And then that's when I paste the string that I had got from the registry on the web browser. Let me get rid of this Docker pool, which is not for Singularity. And so here we go, Singularity pool Docker : / and then the container name and tag or version. And now let's hit enter. And what's going to happen? Singularity is going to just download the container for me. So this is how you translate the compiling and installation process of a package, the example of Ubuntu, by just downloading this container. And I actually, and so the process goes through a set of steps. The last step is creating a zip file. This is the actual container used by Singularity. And in fact, I have now a Ubuntu file here. I've done something bad here. I downloaded the software on the home. I don't really like that because home is small. It's not meant for software. So let me just bear with me. Let me delete it here and go and do it in my Scratch instead, and just repeat the pool. It will be quicker because Singularity caches the pooled images. So here we go. Now it's better. I'm on Scratch. That's where I need to run my workflow. So that's a better place for a container, especially for these training purposes. So let me now use the container. The way to use a container is using, again, Singularity, which is the runtime for containers, followed by exec, followed by the name of the container file, so Ubuntu_2204.zip in this case. And after that, you would just add the command that you want to run in the container. Let me use the cat command to visualize the content of a file that will just tell me the version of the operating system I'm running on. And if you have a look at the output, you'll see that this command was run on Ubuntu 2204. So this command indeed ran inside the container. And in fact, let me just show you, I'm going to rerun the command without using the container. So on the bare login node of Cetonix, I can't even get in the actual operating system of the Cetonix login node, which is /15. So indeed, this previous command was run inside the container. And this is actually how you run commands in a container. This is the actual overhead. So anything you would run, say you have an analysis, you're going to run nwchem in a container, it will be Singularity exec, the container name, and then the very same command. For instance, yeah, nwchem or blast or Python or whichever application you want to run inside the container you downloaded. So that's the kind of learning curve for containers. You need to learn a bit how to use Singularity. We've made it as easy as possible for you on Cetonix, but you still need to be aware of pulling, executing commands in containers. You also need to find a place to keep the container images, the zip files you want to use. It's kind of left to you. Not too big of an overhead, but still a small overhead to pay in order to get the advantages of reproducibility and faster installations. Let me go back here to the slides. The only thing I would add is that other than Docker Hub, the registries I used for the example, there's another one which is quite popular, Red Hat Key.io. This is where a lot of bioinformatics containers are actually stored. And this is an example here for Blast coming from Key.io. This will be the container name to use for pulling, for downloading Blast from Key.io. Just as another example. As a best practice, always some of the container on these registries come with a generic latest tag version. We recommend to prefer the version tags, such as the Ubuntu 2204 that I use and not Ubuntu latest. That's better for reproducibility, because when you provide a version, at least you know better what you're running. So this is just what I showed you. The second bit of another quick note on a small note on GPU-enabled containers, which is currently relevant for our Topaz and Garawarla legacy clusters and will be relevant for Cetonix phase 2. So when you want to run GPU containers with Singularity, there is just an extra flag you need to provide, and you see examples here For NVIDIA GPUs, would be singularity exec --NV, and then the same I just showed you. And for AMD, will be singularity exec --rocam, and then again the CIF file and the command. This is just here for reference. It's not relevant for Cetonix phase 1, but it's relevant for other Pawsey systems, present and future. And this is just the output of the demo I just ran for you. There is now a short exercise. We'll give you probably a couple of 3 minutes for this, and I'm going to run it myself. This is an example of a Python container, and it's just meant for you to refresh on the couple of commands I just showed you. So there is here, this is the Python container I would like you to pull. So Python :3913-lin, give it a go, and I will be back on this one in a couple of minutes. Okay, so let's give this one a go together. So Python container example. By default, the Python tree that is available to create login is 3613. We now want to pull a container for Python 3913. I'm taking this lim tag. It's just downloading a smaller version, smaller installation of this Python container, which takes less time to run. It has less functionality, but it's faster. I tend to forget the Docker prefix. Here we go. Similar to the Ubuntu example, there is this process which is purely a download of data and software from the online registry. And the final step is creating the CIF file. And in fact, you can now see there is a Python container available, CIF file, which I'm now going to use to query the Python version in the container. And it's here, it's 3913. So this command is indeed run inside the Python container. Okay. And so the last part for this training module is about container modules. So what is that? So a container module is just a way, a more user-friendly way to provide a software in a container. So it's an interface to a container. So designed in a way that included software can be run using the very same module commands and traditional commands that I use for any other traditional installation. So basically, deploying a container as module means that there is no extra learning curve in using the software that comes inside the container. So that makes life easier for users. On Cetonix, we use a tool called Singularity Register HPC to automate the process of downloading the containers and generating these container modules that make usage simpler. Under the hood, these modules basically point to shell scripts that hide inside them the Singularity syntax that you would need to use in order to run the container. SHPC comes with a small database of recipes that enable automating the generation of these modules. For instance, on Cetonix, there is a number of applications that look like modules, but are indeed installed as containers. So most bioinformatics packages, the OpenFOAM installations, and some of the Python installations that are available. So let me show this one to you. I'm going to now demo how to use and install these containers with SHPC as modules. So let me load the SHPC module. So that's how I make SHPC available on the Cetonix login node. And now I'm taking again the example of Python. Just it's good because you can find a small container that download in small times, good for the training purposes. So let's pretend I'm looking for a Python container. So I'm going to use the command SHPC show to see if there's any Python container that I can just download and I can just install as a container module on Cetonix. So I'm going to use this filter with the Python string, and I want to see the versions that are available. Oh, it's quite a lot. Let me actually just filter out this output. I want to restrict to slim images just to keep the process smooth. So okay, now it's a bit nicer to read. It was here already, but it was just a longer output. So there is this Python 392 slim container that is available via SHPC. It means I can install it as a container module. And let's see what this means in practice. So this would be the same as basically doing Singularity pool as I did before. But the syntax is SHPC install, and then the container name and version. Well, this was quick because probably I had used this example in the past few days. Let's actually, I want to show you the full output of the installation. So let me remove the previously available container module. Let me repeat the installation. And it's actually a two-step process. The first step is actually the pulling of the container. And you see under the hood, SHPC is actually using Singularity pool. And then after the pulling is complete, and you'll see that the output here is very familiar with what you saw with Singularity, except that the syntax to use it is different. After the pull is finished and the save file is created, and this time it's in a managed location by SHPC. The second component of the SHPC process is the actual creation of the module. So what does it mean? First thing is that the Python 392 is not here in the current directory. It's managed by SHPC. How do I use it? Well, let me just get rid of the SHPC module. So how do I use this Python module I just installed with SHPC? I know it's a container, but it's actually a container module because I used SHPC to install it. And so, well, I use it as any other module, as I showed in the previous training module number 5. So it is now available as a module, just like any other software module on Cetonix. So from this point on, I can almost forget it was a container. Well, I can still see it if I have a look at where the module is stored. There is a container name, kind of hints at that, but that's it. The usage is now the same as any other software module. So I can module load this Python module, and now I'm getting Python 392 from that module. If I load the module again and repeat the command, oh, I now get 2718. This is the one available on Cetonix. So that's it. So this is an alternative way to install container software on Cetonix. You use SHPC install, and after that, you can almost forget it's installed as a container, but you can still get the benefits of running the package as a container. And this was the output I just showed you. In summary, in this module, we talked about container runtime, container modules, and I showed you the key interactions with Singularity and SHPC to deploy containers in a more friendly way as modules. A bunch of best practices that I shared with you, and that was all for the content. On the Pawsey online support portal, we have extensive support documentation that covers a lot of areas in detail. We also have a user support portal. Researchers can reach out there if they have issues that can't solve themselves and they need direct help from Pawsey staff. You can subscribe to the Pawsey Friend newsletter to get news and updates from Pawsey. Thank you. The module is finished and the session is open for questions.